Hello students, I am Dr. S. Natarajan from VMKV Engineering College, Department of Mechanical Engineering. Today we are going to discuss about pneumatic circuits. You know, for bringing many operations in automatic manner, for example, automatic drilling machine, automatic press, or many things nowadays automated, that for bringing some automation we need to design some logical pneumatic circuits. So here we are going to discuss few pneumatic circuits. First going to discuss about some outline of classic methods for designing pneumatic circuits. In this classic method, some logic operations are used. So it's the yes, that means you are providing input here, this valve produce output. So it is the yes function. Okay, the corresponding electronic symbol, logical symbols shown here. That equation, logic equation, it is the truth table, and we are discussing logic function and truth table for designing the classic circuits. So here you pressing this button A, the output 1. So 1 1. If you not press this button, there is no output. So no output, the output also 0. It is the yes function. And you see here in the next one, in this logic, it is the not logic. In this logic, you are not give input, the output is there. Output is not there. Now you see the output is there. Okay. Y is the compressor is connected here, the air is flowing here, and you press this button, the output is cut by this symbol. So you give any signal, the output is not there. If you not give any signal, it is output is there. So normally open switches are designed in this manner. Normally open switches. It is the example of normally closed. And AND operation. In this AND logic, you press, it is the electronic symbol AND logic. You press all these buttons, then only producing out. So it is the AND logic. So here compressor connected, you press this button, up to B only press is there. It is not transferred to A, and again press B, and then to transfer to A, but it is not output from A. Then you press A, then only output is there. So A, B, C, all these three inputs are on, then only output is there. But in this logic here, if any one of the input is not there, no output. So it is given in this truth table. So it is the AND logic. Using this AND logic, we will do many items for starting some important machines. We want to get the approval from superiors. So superior first press that button A, and then after another supervisor level, and then worker level. These three logic is fulfilled, then only output is there, the machine is able to start. So that's why these AND logics are used. And then OR logic. You see this OR logic, that each and every switches are powered with having compressed air. This A connected compressor, B also connected compressor, and C also connected compressor. Here you press any one button, the output is Y is there. You see this logic, you press A, output Y is on, B and C is off, and you press B, output Y is there, or press C, output Y is there. But if you not press any switch, then only there is no output, and you press all the switches, the output is there. So this type of logics are used in, for example, boilers. So boiler having, for example, you take the thermal power plant boiler. Boiler is located some distance away from the control room. The boiler having 3 stop switches. First switch is located in the control room. Second switch near to the boiler. Third switch, security personnel placing in some tower, having some emergency stop button. If you watched any adverse situation is arised at that time, the security person able to stop from his location. Like that, these 3 switches are placed on separate position. One is control room, one is near to boiler, another one is the security. If anyone find anything going wrong, anyone can stop the system. So these OR logics are designed for these applications, OR logic. And NOR logic, it is opposite to the OR logic. So all the buttons are off, then only output is there. All the buttons are in off condition, then only output is there. If any one of the button is on, there is no output. That logic is shown this diagram. It is the electronic logic block diagram for producing the output. Whether a person press A or press B, it produces output. So for that logic only this circuit is designed. So it is the not, if you not press if you press A, that is A bar, there is no output. But you press here, the A signal is coming here, it is the A and B, anyone is there, it producing output, and Y produce the output. Or you press B, it is B is 0, A is 1, so here B is 1, that is it producing, or A and B, and B output is there, and it producing output Y. Whether you may off from A or B. It is the logic electronic circuit given here. The corresponding pneumatic circuit. In this pneumatic circuit, it is the compressor, simple for compressor, it is the F or L, fluid regulator lubricator unit connected, and it is the push valve 4/2 push valve. In this push valve, why it is called 4 means it is having 4 connections. So that is why 4, and 2 position, one is the forward position, another one is the reverse position. So 2 position, 4/2 valve, 2 4/2 valves. This is the valve 1, or it's a valve A, it's a valve B. It is the shuttle valve. It is the, and if A and B output is there, then only it produce output. It is the shuttle valve, it is the OR valve. Any one output is there, whether from here output, from here output, it produce the signal here. It is the direction control valve. The signal is there, it's moving forward. It on and supplying the compressed air here, and it's moving forward. There is no signal, it's cylinder, the spring force bring back to the cylinder. Now it is the construction of this circuit. The working of this circuit, first I press button A. I press the button A, what happened? Now this switch is connected to here. So it is connection is that. So it is having pressure. It is having pressure. And you see this button is not pressed. it is already having pressure. So, it is the AND wall, the two pressure is there, then only it produce output. So, you press A, it having one signal, and already this signal is available, the two signal is there, it satisfied and produce output. This output coming to this OR wall. This OR wall produce output if any one circuit, any one valve producing output. So, now this valve is on and cylinder is move forward. So, you press the button A, it move forward, the cylinder moves forward, okay. And you release it, the power supply is cut and cylinder moving reverse, right. Now, A is not pressed, A is 0, B is 1, what happened? So, A is not pressed, now here the signal 1 available, but B is not pressed, here there is no signal, but case you press B, what happened? Now the compressed air is connected here, compressed air is connected here, this 0 becomes 1. So, already signal is available and this signal comes, it is satisfied, it is also AND wall, and A and B, the two output is available, two inputs are available, two input available and it produce output, and here the output is there, it is the OR wall, any one output is there, it producing output, and it actuates this switch and this switch actuate the cylinder, cylinder moves forward. So, it is the pneumatic circuit diagram for operating a single acting cylinder from two location A, whether location A or location B, if you give signal, the cylinder may actuate. Thank you.